Hi there. We're going to solve today a problem that involves using the sine, cosine rule as well as the concept of bearing. But at first, I would like to revise very quickly the sine and the cosine rule. You know that the sine and the cosine rule are actually applicable on triangles. As you can see here, 3 sides, 3 angles. Always start in alphabetical order. P, Q, R. P, Q, R. So angle P is equal to 47.4. And P small, which is the length, P small, which is the side that is opposite to angle P, which is QR, and it is equal to 40 centimeter. Then angle R is equal to 48. R small is actually the side that is opposite to angle R, which is QP. At last, this is angle Q, which is unknown, and we can always find it by adding the 47.4 and the 48 and subtracting the total from 180. And RP actually represents Q small. Now, let's write the sine rule. The sine rule states that the length of the side over side the angle that is opposite to that side. So, if I say this is side P, this is side P small, which is the 40, because it is right opposite to angle P, which is 47.4, is equal to side Q. Side Q is right opposite to angle Q, which is PR. Over sine Q is equal to side R, which is opposite to angle R, over sine R. So this is my P, as we explained, small p. This angle, we found it by adding the 47.4 and the 48 and then subtracting the total from 180. This is side Q. This is Q small. PR represent Q small. And if we want to substitute, P small is equal to 40 over sine 47.4. Q is my unknown side over sine 84.6 is equal to R side R over sine angle R, which is 48. Now, we're going to actually work with the first and the last fractions, because because we are trying to find R here, right? And we can't take the middle and the last one because Q and R are unknown. Q and R are unknowns. But in here, if I take the first fraction with the last fraction, I have only one unknown, which is R small. So we're going to exclude the fraction in the middle, and we are going to end up with 40 over sine 47.4 is equal to R over sine 48. Let's cross multiply to solve for R. So it's R times sine 47.4 is equal to 40 times sine 48. We're finding R. Again, we're solving for R. So we must get rid of sine 47.4. So we're dividing all by 47.4. So R is equal to 40 times sine 48 degrees over sine 47.4. This is ready to be inserted in the calculator, and we find the final answer as 40.3829, etc. We round it to 3 significant figures, so the final answer will be, we stop at 3. 4 is my first figure, 0 is my second, 3 is my third, stop at the 3, look at the right. 8 is greater than 5, so it's gonna bring my 3 up to 4. So the final answer will be 40.4. Now, let's have a look at this question. And we're going here to use the cosine rule. Just like we did before, we have 3 angles and 3 sides. Now, PQR, angle P capital and side P small is actually equal to 10. Angle Q, so Q capital is unknown. The side that is opposite to angle Q is 11. So 11 is equal to Q small. Angle R, so R capital is equal to 52.1. And the opposite side to R, which is this star or snowflake symbol here, represents R small. So P capital, this is side P, which is the 10. Q capital, this is side Q, which is the 11. R capital is 52.1 and R small is the snowflake. Let's write the cosine rule. Let's start in alphabetical order. If we take the first side, which is P, small letter to the power of 2, is equal to Q squared. What are the other two sides? Q and R. Q squared plus R squared minus, in brackets, 2 times Q times R times cosine P. You started with side P, so you end up with cosine the angle of P. Now, let's start with Q. Q squared is equal, what are the other two sides other from Q? P and R. So P squared plus R squared minus, inside the bracket, 2 times P times R times cosine Q. At last, let's start with side R. Side R to the power of 2. The other two sides are P and Q. So is equal to P to the power of 2 plus Q to the power of 2 minus, inside brackets, 2 times P times Q times cosine R capital. Now let's substitute. If you look at first, P small is 10. So 10 to the power of 2 and Q is 11. 11 to the power of 2 plus side R is unknown. So R to the power of 2 minus 2 times 11 times R times cosine P. If you have a look here, I have two unknowns, angle P and side R. So I can't use this equation. This equation cannot be solved. Let's substitute in the second one. So Q is 11. 11 squared is equal to P is 10. 10 squared plus R squared plus 2 times 10 times R times cosine Q. We forgot to place the brackets here. Please don't forget to place the brackets. And here it's a minus. This is by mistake. Okay? Let's now substitute. But anyway, we can't solve this equation because I have two unknowns, which is R and Q. The last one, R squared is equal to 10 squared. The other two sides, 10 squared plus 11 squared minus, inside brackets, 2 times 10 times 11 times cosine R capital, which is 52.1. This one can be inserted directly in the calculator and r squared is going to be 85.85. Square root each side because you want to find the 1r. So you're going to end with 9.26591, 9057 centimeter. If we want to round this answer to 3 significant figures, 9 is my first figure, 2 is my second, 6 is my third. So stop at the 6. Look at the right, 5 and above. So the 5 is going to bring my 6 up to 7. So the final answer will be 9.27. Now, let's have a look at this question where we're going to use the skills of bearing, the cosine rule, as well as the sine rule. I hope the revision that I made at the very beginning of this video helped you at solving this question. As we're reading the question, we're going to be drawing the figure or a sketch. Please follow up with me step by step. An aircraft flies 500 kilometers on a bearing of 100 degrees. If you look down there, it says finding a bearing that is an angle measured clockwise from the north. So the bearing is an angle that is measured always clockwise and from the north. Now, always start by drawing the coordinates, x-axis, y-axis. So it said here 500 kilometers at a bearing of 100. So the bearing will be measured from the north. So you're going to place your compass on the y-axis and the center of your compass at the origin point, and you're going to measure from here 100 degrees, just as following 100 degrees, and then you're going to draw a line that is 500 kilometers long. So that is my first line. That is a bearing of 100. It's measured from the north. And so I know where the direction of my line, and the length of my line is 500 kilometers. So that is the first line. And then 600 kilometers on a bearing of 160. At the ending point of the line, the first line you drew, you must put the coordinates again. And from the north here, you must measure 160 degrees. Again, you place the compass at the origin, aligned with your y-axis, and you measure the 160 degrees as following. So you know where to draw the line, and the length of the line is 600 kilometers. So this is my bearing of 160, and this is the line of 600 kilometers. So this is my starting point, this is my ending point. If we connect between the 2 points, we're going to have the triangle that we always look for when we're working with bearings. Now, we need to find some of the angles based on the given angles. So, like I said, you always place the coordinates at the ending points. So, this angle is 80. Why? Because this is a co-interior angle, right? If we go back to the finding missing angles, using the rules of finding missing angles, the north is parallel to the north at this point, and this angle is 100. Can you see the U here or the C? So 180. These two angles are co-interiors. So they are complementary, meaning they add up to 180. So that's how I know that this angle here is 80 degrees. Is there any other co-interior angles? Yes, for sure. This 20 here is a co-interior. Can you see this? This is the north and this is the north. And if you can see, this is another U here. So the 160 and the 20 are co-interior angles, meaning they add up to 180. Now, if I want to find this angle here, can you see this angle? This is 160 and this is 80. So if I add the 80 and the 160 and I subtract the total from 360, I'm going to find this angle, which is 120 degrees. Now, let's name the ending points or each ending point in our triangle, A, B, and C. Now, when I named them, remember what we did in the previous two examples when we worked the sine and the cosine rule? We actually named the angles as A capital, B capital, C capital, and we named the opposite side to each angle. So, based on this, angle ABC, which is angle B capital, is equal to 120. And we mentioned how we found angle 120. The opposite side to angle 120 is side AC, which is equal to small b. Now, small c is actually 500 kilometers. How did I know that this is small c? Because it is the side that is right opposite to angle C. And this is side small a, which is equal to 600 kilometers. How did I know that this is small a? Because it is the side that is right across angle A. Now, we're going to use the cosine rule to find the length of AC or B small, in other words. So the cosine rule, we're finding B. So we're going to say the unknown side, which is AC to the power of 2. The other two sides are AB and BC. AB squared plus BC squared minus, in brackets, 2 times AC times BC times cosine ABC. To make it easier, AC actually represents B. So it's B squared is equal AB actually is C. AB is actually C small, and BC is actually A small minus 2 times A times C times cosine B. Now let's substitute. B squared is equal 600 squared plus 500 squared minus, in brackets, 2 times 600 times 500 times cosine 120. Now, B, square root each side because we are trying to find the 1B. And B is going to be square root of 10,000 kilometers. Now, let's use the sine rule to find angle ACB, which is angle C capital. I'm sorry, this one here, we're going to use the sine rule to find angle BAC, which is angle A capital. So as you can see here, A over sine A capital is equal to B over sine B capital. That's the sine rule. Now, let's substitute in this angle, in this formula. So A small is 600 over sine A, which is my unknown, is equal, we found B in the previous step as square root of 10,000 over sine 120. Let's cross multiply. So once we cross multiply, sine A is going to be 600 times sine 120, all divided by square root 910,000. Now we need sine, because we're finding A, we need to apply opposite operation. So we're going to say sine inverse of 600 times sine 120 over square root of 910,000. If you insert this in the calculator, you're going to find, sorry, here once again, you're going to find A as 33.0044916. And if you round it to 3 significant figures, you're going to stop at the 0. You look at the right, there is only a 0, so the final answer will be 33, as you can see. Now, the bearing, we found the distance of AC, and that's what's requested in the first part. And then in the second part, they're asking for the bearing of the finishing point, which is C, from the starting point, which is 8. So you're going to start from the north and you keep going until you hit the line that connects the 2 points together, A and C. So this is 100 plus 33. So the bearing of C from A is 100 plus 33. So the final answer will be 133 degrees. You might have to watch this video a couple of times so that you understand it well before you actually use the exact same steps in solving the following problem. Please try to solve this problem on your own, and I will see you in the next video. Please do not forget to like, subscribe, and share this video if you find it beneficial to anybody else that you know. Thank you so much, and I'll see you in the next video.